Hey there, welcome back to the channel. I'm Brian, and here on this channel we work on fixing ASIC miners, primarily the S17 series, and I guess it's expanding now because really I'm focused more on the BM1397 chip. Why do I say I'm focused on the chip? Well, because I simply can't stop playing with this little Bitaxe board. If we look right there, this is the tester model, right? So it's got a socket on it and got a little OLED screen, tells me how much power the thing's pulling right now, what temperature. It's running at 55C, by the way, and it's only using 7 watts. So this is just a fun little prototype. I'm working to make it better. If you haven't seen this before, check out my other video. I'll put the link up there or down in the description. Let me get this out of the way because we've got something else we need to be working on, or I need to be working on. And that right there is it, this pile of boards. So let me get this out of the way. Okay, so this first board, problem with this first board is, well, it's just got really low performers, right? I've got 1 domain, 2 domain, 3 domain, 4 domains, 5 domains, 5 domains that are absolute zeros. Well, I guess that's a 94. And then I got these 2 weak domains here. Ugh. I've also got this board, which failed to receive replies. Okay, so it's got something probably around the 57 mark, because right there, 57 of 65, it did detect it at one point. And then this board, I pulled it out of the miner. Oh joy. Temp sense problems on 2 and 3. Okay. Another temp sense problem board on sense 2 and 3. So that's 2 temp sense boards, and it failed to detect ASICs. And then a board with weak chips. Now the beauty is, because I have been hard at work with my Bitaxe tester, I got a whole bottle full. That's what I showed you at the beginning of the video. Whole bottle full, about 103 chips that have been tested. They work in the Bitaxe, so I know temp sense works well. The thermals are okay on the chip. So I'm gonna use these. I got a whole pile of chips here that I know are good. Let's get to this one. Okay, let me get the other ones out of the way. Okay, just a reminder, because it's been so long. It's been 3 weeks since I've worked on a board, or over 3 weeks. So on the S17 Plus, the positive connector goes to the one farthest away from the connector here. So positive goes here, negative goes in the middle. Okay, negative, positive. All right, let's find out what the tester says. Yay, 65 chips. Wait a minute. Maybe it was 65 chips. Maybe it's not. All right, now it's 65 chips. It can't decide. Let's take the voltage down to 17 and a half. There we go. Let's see how it runs at this low level. Ah, there we go. Aha. What am I talking about, right? Oh, there we go. It was 36. For just a moment, it was 36. Then it warmed. Once it got warmed up, it was okay. So look at that. If I look on my sheet here, 36 is where we get some weakness. Okay, let's go lower and see what happens. Okay, down to 17. Okay, chips have kind of gotten warmed up. I think we're probably not going to see anything. So what I'm going to do is I'm going to reflow the domains. I'm just going to, that'll probably be the easiest thing to do. Let me get this torn down, and then probably I'll clean it off. All right, so I did some extra cleaning on this one because since I'm going to reflow all of these chips, I want to make sure that in the process I don't get any of the thermal paste messed up in the flux, right? So I got all the joints as good and clean as I could, really scrubbed them, cleaned them out good. I'm going to also go ahead and fix, before I start reflowing things, I'm going to fix these 3 spots here, here, and here. Those 3 spots right there that the nuts fell off, right? So since the nuts fell off, let's go ahead and put the nuts back on. And let me do that right now. Got a little bit different process than I've been doing in the past. We're going to use the new technique. Let's start by getting the solder nuts all fixed up. Okay, so while I'm waiting for my desoldering iron to get warmed up, that's the only thing I don't like about my Yahuwah, is that it takes a bit of time to warm up. But in the meantime, let's open up this package that came in from Thanos. We'll do it together. Literally, I know what should be in it, but I don't know if it's actually in there. So let's find out. Together. Ooh, I know what this is. All right. Check it out. This is the green thermal paste. So now I've got the pink and I've got the green. What's the difference? Well, this is like 6.5 megawatts per joule, or I think whatever the milliwatts, whatever it is, of heat dissipation. This is 6.5, and I think that this is like 3 or so. So my plan, I'll use this on the cool side of the board, and I'll use this on the warmer side of the board. There we go. All right, so what else did I get? These are fun. They like to really pack these in tight. All right, there we go. 2 more sockets. So John, if you're watching, there you go, man. These are for you to do your machining magic to. Anyway, I'll see you in a couple of days and we'll get these things built, right? All right. 2 more sockets for Bitaxe testers. Cool. All right. My desoldering iron is warmed up. So what I've started doing, thanks to Off the Wall and his suggestion, is I strip off the old solder, and then I put on new. I clean it up really good, and then I put on new solder. I also started using my desoldering iron because, well, it's just easier. All right, looks like I got just a little bit more to do right there. I can't do it from the side. Thanks to YouTube magic, I got it cleaned up. All right, I'm going to keep repeating that process, and I'll do it to the other 2. There we go, nice and smooth. No solder. It's all been taken off. Okay, good, good, good. All right, so the next step in this process that I've been doing now that gets the better mount. All right, all cleaned up now with my soldering iron ready. We'll go ahead and put some flux on, tin this up with leaded solder. All right, so that's got It's got the pad sites all ready to go, and right over here I've got my nuts that I'm going to put back on there. So I'm going to put this on my jig, and then I'm going to heat from underneath. So basically I hang it off the side of the board. You don't need a jig like this to hold it out there, but if you don't have one, you can just hang it off the side of your bench. I happen to make a jig for this, so I'm going to use it. I'm gonna put this back on the microscope cam though, so I think that's the best way to watch this work. Set my air station at 425, 80 on the airspeed, more flux. Okay, as soon as I've got the bottom kind of warmed up, I can see the chip starting to melt. I come in on the top with the iron, put more heat into it. There you go. Just like that. When I mount them like that, they don't come apart. All right, so it looks like I need to actually I need to reflow zone 1 or domain 1, right? So really I already did that with chip 5. I'll just double check it. For this I'm going to use a bent tip. Still the same temperature at 425 and 80 on my airspeed. All right, so that's chip 5. Put some flux on there. All I'm doing is looking for those to get nice and shiny and silver again. I'm gonna go ahead and give myself a little bit more air. Go to 500 and 100. There we go. Alright, there we go. We got it all nice and shiny for domain 1. I'm going to let that domain cool off, and then I'll keep doing the same thing on all the others. Alright, welcome back. I have managed to get through all the domains. I did 1, 2, 3, 4, 5, 6, 7 of the 13 domains. Ever wonder why no one actually shows reflowing the entire board? Because when you do it with a hot air station, it takes a while. All right, board is nice and cool. Let's see what we get. Hey, look at that, 65 chips. Dog, I didn't destroy the board. All right, let's go ahead and check our temperatures. I got all my chips running. Looks good. I'm gonna go ahead now. Let's go ahead and stop the test. Let's take our voltage down. Take it down to 17 flat. Okay. See if we run a quick chip test. Oh, looky, looky, looky. So we go way low like that, and now we have a problem. Okay, let me get my jumpers. Jump in here, and we'll grab... Okay, I know I got good 30. Good 40. 43, 44, let's jump over here to 45. 45 is good. Okay, looks like that's our weak chip, so we'll go ahead and replace that one. Right, so we're good all the way through here, but that one is not. Okay, let's take that chip off. The kicker was I didn't replace that chip. I didn't flow that chip or anything. Let's reflow that chip. Okay. All right, that's cooled off. We're still running at 17 volts. Let's see what the tester says. Okay. Don't have any chips. Let me grab my jumpers. Cool. 49 chips. Jump over to this domain to get this one. So we'll go ahead and replace that chip. All right, I'll show you the swap out part. I'll show you the what I actually physically do first, and then I'll show you what's on the screen. All right, so first thing I do is I disconnect the USB. So this is, oops. So I disconnect the little USB, so that's running CG Miner. I don't worry about taking the power off. I just flip it up. When I flip it up, I grab the chip that I'm running, because I'm running basically a lottery miner right now, trying to hit a block. All right, so this is my chip I just pulled out. It's cool. They cool off real quick. Make sure you get the positive side. Let's go. So you get the positive up to the top, pin 1 to the top corner there. Okay, then I just pull it down, and I'll see that the temperature goes to 45°C. That tells me that the temperature sensor in the chip is working right. And now I'll just plug it in. And I'm going to flip over to the screen here, plug in, and you'll see a hot plug. There's the hot plug. Now let's find out if it can get a chip. Okay, it did find the chip, so the chip is okay. I'm gonna let it run, and we'll see how the chip goes. If the chip drops below 225 megahertz, then I'll put this in my bag of suspect chips. But at least it looks like the chip was good, so maybe, oh, look at that, it found a block. Yay. I'm sorry. 6 point something Bitcoin. No, it did not find a block. It found a share. Submitted a share. There it goes. It's just submitted another share. Okay, so anyway, I'll let this tester run and see how this chip performs over a little bit of time. That would be too funny if I actually found a block on camera. Yeah, I think it's like 6.3 Bitcoin. It's like almost $170,000, depending on where the market is right now. How cool would that be, right? Off a little Bitaxe tester. All right, if you want to build your own, you can get the code from the Bitaxe GitHub repository, or you can build the one I'm working with by going to the link that's down in the description. All right, let's see what we got. There we go. Okay, 65 chips. So that's 65 chips running at 17 volts. That's good. Let's see what the temperature readings, how they do. Okay, we got 65 chips again. Good, good, good. Boom. We got all the chips. So I like it. I'm very happy with it. I'm going to go ahead and put the thermal paste on, and then we'll get this thing going. Now, one thing, let's talk about thermal paste. So I've got two different thermal pastes. I've got the green and I've got the pink. The thing is, the board, this side of the board is the hot side, right? So the air blows in from here on your screen. It would be the top side. The air blows in. That's where the fan intakes are. Blows in. It gets really hot on this side because you've had all the time for the heat to build up. So what I'm going to do is I'm going to use the pink stuff on this row right here, and I'm going to use the green stuff on this row and see how that does performance-wise. Okay, so this is interesting. The first time I've used it, literally just trying it on camera right now with you. So this stuff is definitely thicker than the pink stuff. So I may want to change out the size of my tip. I'm using a 10 gauge. I may drop this down to 12 gauge. I'm going to show you something real quick. This is for one of the guys in the Bitaxe Discord channel. We were talking about heat sinks the other day and touching the tops of the chips. So this is a monolithic block. Of course, I've split this into 3 different zones, but I want to point out to anyone who's curious, there is an insulator where the screws go through. So these screws and the nuts, they are insulated because you're connecting in between the domains. So there is potential, there's voltage potential between the nuts. But there's no insulation at all on where the heat sinks actually touch the chips. So it works. And the only insulation you've got is the thermal paste. So obviously I wouldn't put these direct on metal to metal. That's why I use the paste, or I would use thermal pads. Looks like I had one screw that the nut popped loose, but that's okay. It's right here on the edge, so we've got good contact. I'm not too worried about it. All right, so that's chip 41. If I start having a heat problem, I'll pull this board back out and fix that nut. Right now, I'm not too worried about it. All right, we'll do one last check just to make sure. Good. 65 chips. We're still at 17 volts. That's really good. Really good. Okay, let me get this in a miner and I'll tell you how it goes. All right, well, I've got the board hashing, and if we go back, right, let's look at this. So I've got it hashing right now at 18.8 volts, and at 18.8 volts, we've got the last 3 domains right here. We've got them completely dropping out, or dang near dropping out. And then we also have this 11 through 15, so domain 3. Now if I look back at my notes from beforehand, so what I notice when I look at this is that we have the same issues. 11 through 15 was a problem then, and as well as at 56 through 60. So I think I made some, let's go back to it and you can see what I mean. If I just do an A-B comparison, right? Now granted, I'm at 18.8 versus 18.6, but I'm also running a higher frequency, and I've got 4 bad domains, whereas before I had 1, 2, 3, 4, 5, 6 bad domains. So I think I've made some progress. So the thing I'm really excited about is the temperatures, right? Man, now that 75, that would be chip 11. Now chip 11 is one of the chips I'm having a trouble with. But look at that. Look at that fourth temperature sensor. Okay, so that's at chip 51. That's the chip I replaced, and that's also running that green paste. Wow, 60 degrees. It's actually cooler than the intake up there on temp sense 1. So definitely a good improvement. I think I like the green stuff. It's $27 a tube. I'll put the link down in the description below if you want to get some. The pink stuff works really well too, so you can use a hybrid mix like I'm doing if you like that. So I'm not going to consider this board massively fixed, but it is hashing more now than it was. So it's working better. So I'll leave it in there, let it run for a few days while I work on the other boards. I've got 3 other boards I've got to get fixed. I just wanted to kind of circle back before I ended this video with the chip that we pulled off, right? That was chip 51. I got taken off the board, and I cleaned it up and I put it in the Bitaxe tester. And if I go to my screen here, you can see it's been hashing. It's now down at 200. So for me, anytime I see a chip that runs less than 225, I go ahead and I put that in my bag of chips less than 225. So that's what this bag of chips is right here. I probably have well over 100 chips that they'll hash. They just won't hash at high speeds, high frequencies. So I'm holding on to them for whatever reason. Maybe I'll learn something new, and then I'll be able to reuse these chips. Thanks so much for watching. If you enjoyed this video, please give it a thumbs up. If you haven't already, please subscribe to the channel so you'll get notified when I put out new content. More than 90% of my viewers are not subscribed to the channel, so you're missing out every time I put out a new video. Thanks again for watching, and I'll see you soon.